Okay. Good evening to all of you. In previous lecture, we have discussed about the Sturm-Liouville's problem. Today, I will discuss about the orthogonal property of Bessel's function. Okay, as you know that x square y double dash x y dash plus n plus 1, sorry, x square minus n square, x square minus n square y is Bessel differential equation of order n. Okay, and solution of this Bessel differential equation is Jnx, and domain for this differential equation is defined as x greater than 0. Okay, when we are substituting, after simple substitution, modified Bessel differential equation corresponding to this equation is x square y double dash plus x y dash plus, या कहें अगर हमने यहाँ पे सब्स्टिट्यूशन लिया है x इक्वल टू के टी, लेट देन इट इज टी स्क्वायर टी वाई डैश k square t square minus n square y is 0. Here this y prime is dy by dt. Okay, because but we can also replace this t by x, just केवल एक सिमिलैरिटी राइटिंग के लिए लिख सकते हैं वह, अच्छा ऐसे भी लिख के छोड़ दीजिए तो कोई दिक्कत नहीं है. तो ये हमारी डिफरेंशियल इक्वेशन हो गई. दिस इज कॉल्ड अ मॉडिफाइड बेसल इक्वेशन. मॉडिफाइड बेसल इक्वेशन. बेसल इक्वेशन. Okay, solution for this equation is yx is ytx, यानी कि jnx सोल्यूशन होता है इस इक्वेशन का. इसका सोल्यूशन जो होगा वो होगा jn tx, नहीं kt, सॉरी, it will be kt. So solution for this modified differential equation will be jn kt. Okay, now this is the solution of one of the solution of this modified differential equation. This differential equation can also be write as ty dash plus y dash plus k square t minus n square by t. Y is 0, and this part can be write as d by dt t into dy by dt and n square by ty. This will this is qt here, and k square ty 0. Here this k square is parameter lambda. Lambda is k square here. So it is our, this equation is now in the form of Sturm-Liouville's equation. Okay, now Bessel equation in Sturm-Liouville's form is of this type: d by dt t into dy by dt. Q is here n square by t y plus k square ty 0. Okay, so here Bessel differential equation, modified Bessel differential equation is written in Sturm-Liouville's form. Okay, so it is Sturm-Liouville's form. Here RT is solution of this differential equation is y is jn kt. Okay, rt is here t. Okay, domain for this equation is from t greater than 0. It means that this side t is greater than 0. This will be the domain. Okay, if we are restricted this domain in bounded, या कहें कि हम finite interval एक ले रहे हैं, बाउंडेड इंटरवल ले रहे हैं फ्रॉम 0 टू से इट इज r. एक इंटरवल यहाँ कंसीडर कर रहे हैं 0 टू r, फाइनाइट इंटरवल कंसीडर कर रहे हैं. तो फाइनाइट इंटरवल के लिए इसकी इक्वेशन क्या होगी? मॉडिफाइड बेसल डिफरेंशियल इक्वेशन. सो डी बाई डी टी t dy by dt, here this n is fixed. For fixed n n square t y k square t y 0. So as you know that here rt is 0. Interval is now, because we are considering only the bounded interval here, which is t lies between 0 to r. T lies between 0 to r. So yes, t is lies between 0 to r, या कह सकते हैं t belongs to interval 0 to r interval. Okay, so now in this interval, because it is Sturm-Liouville's form में लिखा हुआ है, and rt is equal to t. So at the lower boundary where t is 0, r0 is 0. r0 is 0. So if r0 is 0, यानी कि lower end a, हमें पता है अगर Sturm-Liouville's equation defined है a to b interval में, and either of the end point, if this r multiply with the dy by dt, coefficient of this dy by dt here, if this coefficient is 0 at the end point, either of these coefficient either of these point or both of this point a and b, if this r is 0, then this SLP is known as singular SLP, singular Sturm-Liouville's problem. और अगर ऐसा है जिस पॉइंट पर हमारे पास जिस एंड पॉइंट पे आर ए 0 हो जाता है, at that point we can leave this, we can drop the boundary condition. So at the point x is equal to a, we can drop the boundary condition. It says that y and y dash at the point 0 is finite. This says that because it is r0 is 0, so this says that y0 and y dash 0 are finite at t is equal to 0. Okay, so second boundary condition was, you know that second boundary condition will be b1 y, because we are taking here the last end point b is equal to r. जो हमारा दूसरा एंड पॉइंट है वहां पे b की वैल्यू हम कैपिटल r कंसीडर कर रहे हैं. सो b1 yr प्लस b2 y डैश r विल बी 0. इस इक्वेशन के अंडर हम इसको सॉल्व करेंगे. Okay, as we know that both b1 and b2 cannot be 0, so here we are choosing particularly b1 is not equal to 0 and b2 is 0. So our boundary condition will be b1 yr is 0. b1 is non-zero quantity, so this equation will be reduced to yr is 0. So solution is saying that yr is 0, and you know that ओरिजिनली जो y था वो क्या था? फंक्शन ऑफ x था, पर यहाँ पे x को हम लिख रहे हैं kt. तो इट मींस दैट yr is 0, यानी कि y, you know that yx is here jn kt. So yr 0 means jn kr is 0. So this equation will be 0 at this point r. तो नेक्स्ट बाउंड्री कंडीशन जो हमारे पास है वो दे रही है, इट इज इक्वेशन जे एन के आर. इट मींस दैट दिस के इज अ रूट ऑफ दिस आर. अब इस इक्वेशन जो हमारे पास ये इक्वेशन आ रही है बाय यूजिंग स्टर्म-लियोविले's कंडीशन, सो दिस कंडीशन सेज दैट दिस इक्वेशन हैज, क्योंकि हम इसके नेचर को जानते हैं बेसल फंक्शन ऑफ फर्स्ट काइंड, सो दिस इक्वेशन हैज infinite number of zeros. say KR. Okay, infinite number of zeros. Say that these zeros are A1n, A2n, n इसके लिए ले रहे हैं because fix n के corresponding हम यहाँ पे ले रहे हैं A1, A2, A3n and so on. Or we can write KR because for this KR it is 0. So when KR is equal to either of these values, yani in general we can write it MN, where this M is 1, 2, 3 and so on. It means that K can be write as KM. KMN is, यहाँ से K की वैल्यू निकालिए किस K के लिए, this JN will be 0. It will be 0 for K is equal to AMN upon R. KMN upon R. So here M is 1, 2, 3 and so on. So these will be the root for this differential equation. This equation J and KR is 0. If we are considering a equation J and KR 0, so roots for this equation will be this KR will be the roots of this equation if K takes the value AMN upon R. Okay. So this is the, ये इसका पार्ट है, इसको जानना जरूरी है कि कब यहाँ पे इसके रूट्स 0 होंगे. Now orthogonality says that orthogonality of basic functions is that if let orthogonality of Bessel function, orthogonality of Bessel function. Okay, let या कहें if lambda I and lambda j are roots of equation j n lambda a की हमने r की जगह पे यहाँ पे a लिख लिया फॉर सपोज lambda I lambda j are root of the equation. इस equation के roots हैं where when lambda takes the value lambda I, then this will satisfy this equation, and when lambda takes the value lambda j, then again this equation will be satisfied. Okay, so if lambda I and lambda j are the root of this equation j and lambda a is equal to 0, then integral over this interval from 0 to a with weight function x jn lambda I x jn for fixed n. Here this n is fixed. N is fixed here. Jn lambda jx dx. It will be 0 if I is not equal to j and its value is a square by 2 jn plus 1 lambda I a. Lambda I jn square, sorry, jn plus 1 square. And when I is equal to j, when both the roots are same, then value of this integral will be a square by 2 jn plus 1 square lambda I a. Okay, this can also be write as, this expression can also be write as a square by 2 jn plus 1 square of lambda I a into delta ij, where this delta ij is called, it is known as conical delta. Conical delta. Conical delta function, its value is 0 when this I is not equal to j and its value is 1 when I is equal to j. Okay, it is the statement for the orthogonality property of Bessel function. Okay, now we have to prove that. Sorry. Okay, so first of all, here we are taking lambda I is not equal to lambda j. First case is when lambda I is not equal to lambda j. And it is the roots of, they are the roots of j and lambda a. It is given j and lambda a. This is the roots of this equation. Okay, therefore, it will satisfy j and lambda I a must be 0 and j and lambda j a will be 0. Say that it is equation number 1. Okay, again, here we are taking, denoting this j and lambda I by j and lambda x by ux. J and lambda ix, we are denoting this function by ux, and j and lambda j x by vx. Say that it is 2. Giving name to this expression 2. Okay. Then this u and v, as you know that this u and v must be a solution of modified Bessel differential equation. So they must be a solution of u, x and vx are Bessel function, satisfying modified Bessel equation. Modified Bessel equation रिस्पेक्टिवली क्या है बेसल इक्वेशन हमारी होंगी एक्स स्क्वायर वाई डबल डैश प्लस, हम यहाँ टी की जगह एक्स ही यूज कर रहे हैं, सो आई एम राइटिंग हियर एक्स स्क्वायर वाई डबल डैश एक्स वाई डैश प्लस lambda I square x square minus n square y is 0. Say that it is equation number 3. Okay, and another equation which is satisfied by v. यहाँ पे चाहे तो हम y की जगह पे u भी लिख सकते हैं. We can write here u in place of this y. U double dash u dash u. Okay, and equation which is satisfied by this function vx will be x square y double dash x y dash plus lambda j square x square minus n square v is 0. Say that it is equation number 4. It is equation number 4. Now, multiplying in equation number 3 both side by v and multiplying in equation number 4 both side by u. Then subtracting equation 4 from this equation number 3. Okay, जैसे हमने ऑर्थोगोनल प्रॉपर्टी स्टर्म लिउविल में दिखाई थी in the same manner. So it will give you x square u double dash u minus v double dash. Okay, x square v u double dash minus u v double dash plus x v u dash minus u v dash plus x square n स्क्वायर यू वी, ये दोनों कैंसिल हो जाएंगे सब्ट्रैक्ट करने पे, तो केवल लैम्डा वाले टर्म्स बचेंगे हमारे पास. सो वी कैन राइट हियर लैम्डा आई स्क्वायर माइनस लैम्डा जे स्क्वायर u into v is 0. Okay, so in place of these two terms we can write here, first of all we are dividing this whole equation by x, so we will get x v u double dash minus u v double dash plus v v u dash minus u v dash plus x lambda I square minus lambda j square u v is equal to 0. So In place of these two terms, we can write here d by dx x times v u dash minus u v dash plus x lambda I square minus lambda j square uv is 0. This equation, say that it is equation number 5. This equation can also be written as x delta j square minus lambda j square minus lambda I square u into v is equal to d by dx of x vu dash minus uv dash. Okay, say that it is equation number 6. Now integrating both sides of this equation number 6 with respect to x from a to b, it will give you delta j square minus delta I square integral from 0 to a x u into v dx is equal to 0 to a d by dx x of okay, v u dash minus u v dash into dx. So after integrating on the right hand side, we will get x v u dash minus u v dash from 0 to a. 0 to a. Okay. Now lambda j square minus lambda I square integral 0 to a x u v dx is x v u dash u v dash from 0 to a. Okay. Now substituting the value of u and v here. So lambda j square minus lambda I square 0 to a, u was jn lambda ix and v was jn lambda j x dx. And also on the right hand side, v was jn lambda j x and this was jn lambda I x whole prime minus jn lambda I x jn dash lambda j x and limit from 0 to a. Now substituting this limit here on the right hand side, we will get in place of x we will write here a, then v was jn lambda j a jn lambda I a minus 0 in place of x substituting 0, so all the term एक second, sorry, substituting here x is equal to 0 in the whole part. Okay, it will give you 0 j lambda I and jn x. Okay, 1 second. Minus jn lambda I a and jn dash lambda j a is this. At the point, at the lower limit, total value will be 0. Okay. So now, as you know that lambda I and lambda j are the roots of j and lambda a. It means that j and lambda I, this term will be 0 and this term will be again 0 by using equation number 1. So right hand side of this equation becomes 0. So we will get finally lambda j square minus lambda I square from 0 to a x j and lambda I x j and lambda j x dx is 0. As we know that lambda I is not equal to lambda j here, for I not equal to j. So this is, they are unequal. It means that this factor will be not, this factor cannot be 0. It will imply that integral from 0 to a jn lambda I x and jn lambda j x dx is 0. So it will be the orthogonality condition when I is not equal to 0. Now we have to consider the case when I is equal to j. Okay, so for I is equal to j, in place of j and lambda I x, we will get j n square lambda I x dx. Okay, because we have to prove that 0 to a x jn square of lambda I x dx is 0. Okay, so for this purpose, we will use here again the equation number third. That was, equation number third was, yes, it was the equation number third, modified Bessel equation satisfied by U. Okay, so equation was x square u double dash x u dash plus lambda I square x square minus n square u is 0. Okay, now in this equation, multiplying both side by 2u dash. So multiplying both side of this equation by 2u dash. So when multiplying both side of this equation by 2u dash, we will get x square u dash u double dash plus 2x u dash square plus lambda I square x square n square 2
एक्सक्यूज
times
मी मैम.
when u dash is equal to 0. Yes.
मैम ये जो लैम्डा आइगन वैल्यूज है हमारी, ये पॉजिटिव ही होगी मैम, नेगेटिव तो हो नहीं सकती.
नहीं, ये भी यहाँ पे इसको प्रूफ किया गया है, ये भी हमारे पास पॉजिटिव ही होगी. क्यों पॉजिटिव होगी? अभी लैम्डा आई की वैल्यू निकाली गई थी, हमने रूट्स लिखे थे यहाँ पे AMN अपॉन आर. आर क्या था? हमें पता था जो हमारा डोमेन है टी इज ग्रेटर देन 0 था, वहां पे हमने टी लिखा था इन प्लेस ऑफ एक्स.
यस
तो
यस.
डोमेन हमारा टी था, सब इस तरह वैल्यू थी, तो जीरोस भी हमारे इस साइड पड़ रहे थे. तो ये सारे जीरोस थे हमारे बेसल फंक्शन ऑफ फर्स्ट टाइम के. तो ये
यस
सारी वैल्यू होगी एक्स पर ही, तो ये वैल्यू पॉजिटिव है. आर भी हमने यहीं कहीं लिया था, तो आर भी पॉजिटिव है. सो ऑल दीज वैल्यूज आर पॉजिटिव. तो लैम्डा आई वाज mn अपॉन आर, दैट्स व्हाई इट इज पॉजिटिव.
ओके
ओके.
मैम.
Okay, so I have multiplied 2u dash both side of this equation. Okay, actually I have multiplied by 2u dash because I want to make it in perfect derivative बनाना चाहते हैं, total derivative किसी function का exact derivative बनाने के लिए 2u dash से हमने multiply किया है. Now you can see that this is the total derivative of x square u dash square. It means that we can write here x square u dash square, and ये वाला जो है ये है हमारा 2 times n square u dash. This can also be write as n square minus time n square u square. So minus of n square u square. Now come on this face. It is 2 lambda I square एक्स स्क्वायर यू एंड यू डैश। इस टर्म को भी हम परफेक्ट स्क्वायर बनाना चाहते हैं। परफेक्ट स्क्वायर बनाने के लिए वी हैव टू ऐड एंड सब्ट्रैक्ट अ पर्टिकुलर टर्म। सो आई एम एडिंग हियर यू यू डैश। ओके, एक्स के टर्म में डिफरेंशिएट करना है। सो हियर आई एम एडिंग 2x lambda I u square and also subtracting this term. तो सब्ट्रैक्ट करने के बजाय हम इसे राइट हैंड साइड पर लिख लेते हैं। 2x lambda I u square. Adding both sides, this term 2x lambda I u square and 2x lambda I u square. Now, the total derivative will be of the function x square u dash square n square u square, and it is derivative of lambda I square. Yes, it should be lambda I square. Lambda I square x square u square is equal to 2x lambda I square u square. Say that it is equation number 4, 5. This is 7. It is equation number 7. Say 1 second. In equation number 8 इसको बोल देते हैं equation number 6. Sorry, this is equation number 6. Okay, so it is equation number 7. Now integrating both sides of this equation number 7 with respect to x from 0 to a. From 0 to a, 0 to a, integrating d by dx, x square u dash square minus n square u square plus, yes, plus lambda I square x square u square dx, and on the right hand side it was lambda I square 0 to a x yes 2x u square yes 2x u square dx. Okay, so on the left hand side we will get, this can be write as lambda I square 0 to a x square u square dx. It is equal to x square u dash square minus n square u square plus lambda I square x square u square limit 0 to a. Now in place of this u substituting, because we know that ux is j and lambda I x. So substituting this both side. So we will get 2 lambda I 0 to a, 2 lambda I square 0 to a x j n square of lambda I x dx. Now x square j n dash of lambda I x whole square minus n square j square n of lambda I x plus lambda I square x square j n lambda I x. Okay, 0 to a. Substitute कर देंगे lower limit and upper limit. So we will get a square j n lambda I x whole derivative at the point x is equal to a. Sorry, derivative, it's a square at the point x is equal to a minus n square j n square lambda I a. You know that j n lambda I a. This is the lambda I is the root of j n a. So ये term हमारा 0 हो जाएगा. And lambda I square x square j n square lambda I a. This term will be again 0, because lambda I is root of j and lambda a. So this term will be 0 and this third term will be again 0. And next at the lower limit, when we are substituting x is equal to 0. So x is equal to 0 substitute करेंगे the first term 0. Then on the second term j and 0. You know that Bessel function at the point 0 इसकी value 0 होती, तो this term will be 0 and third term will be again 0 by the same reason j and 0 is 0. So finally we get only this term. Value of this integral will be a square jn dash of lambda I x square at the point x is equal to a. Okay, so we get 2 lambda I square 0 to a x jn square of lambda I x dx is equal to a square jn dash lambda I x whole square at the point x is equal to 0. तो फर्स्ट ऑफ ऑल क्योंकि इसकी वैल्यू नहीं जानते हैं तो हम चाहते हैं कि जे एन एक्स के टर्म में लिखें इसे. So we will use here a reconciliation. Reconciliation for Bessel function of first kind is jn dash x is equal to n by x jn minus jn plus 1x. Okay, this is a derivative, means derivative with respect to x. We can write it as d by dx. Now we have to find the reconciliation for this function lambda ix. In place of this x, we have to replace here x by lambda ix. So this will give you d by of lambda ix with respect to lambda ix jn lambda ix n by lambda ix jn lambda ix minus jn plus 1 lambda ix. Okay, this will give you 1 upon lambda I d by dx of jn lambda ix is equal to n lambda ix jn lambda ix minus jn plus 1 of lambda ix. Okay, so from here we can find the value of jn dash lambda ix is jn dash lambda ix is n by x jn of lambda ix minus lambda I jn plus 1 lambda ix. 1 second. Yes. Now substituting this value, first of all we have to find this value for lambda ia at the point x is equal to a. Substituting x is equal to a here, so we will get n by a jn lambda ia minus lambda I jn plus 1 lambda ia. We know that jn lambda I is 0, so this will be 0. So jn lambda I is equal to minus times lambda I jn plus 1 lambda I into a. Now we have to find its square, jn dash lambda ia whole square. This will give you lambda I square jn plus 1 square lambda I a. Now substituting in place of it in our previous integral. So our integral will be 2 lambda I square 0 to a x time jn square of lambda ix dx is equal to a square lambda I square jn plus 1 square lambda ia. Okay, lambda I square both sides से cancel कर देंगे. So finally we will get integral from 0 to a x jn square lambda I x dx is equal to a square by 2 jn plus 1 square lambda ia. Say that it is equation number 8. It is equation number 8. Now combining equation number 6 and 8. Combining the equation number 6 and 8, it give us 0 to a integral x jn lambda ix and jn lambda jx dx. Its value is 0 when I is not equal to j, and its value is a square by 2 jn plus 1 square lambda ia. Okay, so this is orthogonal property for the Bessel function. Okay, so ये प्रॉपर्टी की तो बात हो गई, एक छोटा सा टॉपिक और है. यस, फोरियर बेसल सीरीज. जैसे हमने उसकी सीरीज लिखी थी, we can express a function in terms of Legendre polynomial in the same manner. We can also express a function, expand a function in a series, or in a series where in a various order in terms of Bessel function, various order Bessel function. Okay, so first of all, we can say that we have a function fx which is defined on an interval, a bounded interval from 0 to a, and we suppose that it has an expansion of this form ci jn lambda ix, where the ci are some constant multiplied with various order Bessel function of first kind. Okay, so now we know that this lambda I is root of this equation j and lambda ia. It is the root of this equation, so it must satisfy j and lambda ia is equal to 0. And we will use the orthogonal property of Bessel function of first kind over this bounded interval 0 to a. We can evaluate this coefficient c1, c2, c3 and so on. Okay, so first of all, we are taking this equation 1, fx is equal to summation I going from 1 to infinity ci jn lambda ix. Suppose that we have a function and we can write this function like ci jn lambda I x. Yes, and I going from 1 to infinity, which can be write as c1 j1 jn, n is fixed here, lambda 1x, c2 jn lambda 2x plus c3 jn lambda 3x plus so on. So for writing this function in this form, we should know about this coefficient c1, c2 and c3. So multiplying both sides, because in general we want to evaluate the cn. So multiplying both sides of this equation by x into jn lambda nx. Both sides of this equation, say that it is equation number 1. Multiplying both sides of this equation by x times jn x. Yes, so we will get here, one second. अच्छा, in general lambda z then n के लिए लिखेंगे. Okay, yes. ओके, मल्टीप्लाई करते हैं बोथ साइड. uh, 0 to a, then integrating from 0 to a with respect to x into fx jn lambda nx dx plus is equal to c1 integral 0 to a x jn lambda 1 x jn lambda n x dx plus C2 0 to a x jn lambda 2 x jn lambda n x dx plus so on. Nth term will be Cn 0 to x x into jn square lambda n x dx. This will be the function. You know that by the orthogonality property, all other जितने भी integral होंगे all will be 0. Only we will get the coefficient Cn. So you can find from here the Cn will be 0 to a x fx jn lambda n. अच्छा n यहाँ पे लिखा है इसलिए इसको यहाँ पे आई जे के फॉर्म में लिखा होगा. यस, वन सेकेंड, आई वांट टू सिंप्लीफाई समथिंग. बोथ जगह पे हमें n नहीं लिखना है. We will take here j because we are writing here n. So j, we will use here j, and in place of cn here also I will use j. Okay, and this will be also j. So when I is not equal to j, all the integral will be 0 due to orthogonal property. Jn lambda j x dx equal to Cj integral 0 to a x jn square lambda j x dx. इसको हम पहले से इवेल्युएट कर चुके हैं. इसकी वैल्यू होगी a स्क्वायर बाई 2 jn plus 1 square lambda j a. Now from here Cj is equal to, Cj is j, where j going from 1 to 3 and so on. Cj is integral from 0 to a x fx jn lambda j x dx divided by a square by 2. So we can write 2 here. A square jn plus 1 square lambda j a. So this will be, in this manner we can find the various coefficient multiply with jn lambda 1, jn lambda 2, jn lambda 3 and so on. So in this manner we can expand any function defined over the bounded interval as a in form of Bessel function of first kind with the fixed order. Yes. यहाँ पे कुछ इसके एग्जाम्पल्स हैं, उनके लिए हम बाद में किसी क्लास में इनको डिस्कस कर लेंगे. ओके, so here our second unit is completed. Next class, in the next class I will start third unit with the which was the complex analysis. So some differentiation, analytic function, differentiation, continuity of a complex valued function we will discuss there, and also we will start the start from the most important topic, which is analytic function. Okay, so in this next class वहाँ से हम start करेंगे.
ओके.
और अभी इसको तैयार भी कर लीजिएगा कि नेक्स्ट जो अब हम टेस्ट लेंगे क्विज, वो हमारा हमने कहाँ तक ले लिया था, लैग्रेंज लीजेंडर पॉलिनोमियल का टेस्ट हो गया था, है ना. लेकिन उसकी कुछ और प्रॉपर्टीज वगैरह के साथ लीजेंडर भी, बेसल्स भी और स्टर्म लिउविल थ्योरम.
ऑर्थोगोनैलिटी प्रॉपर्टी तो
हाँ, ये सारी चीजें. यस, डेट में बता दूंगी बाद में. अभी
मैम ये वाली पीडीएफ प्लीज अपलोड कर दीजिए.
कर दिया, अपलोड है, सारे पीडीएफ अपलोड है. कॉम्प्लेक्स का भी मैंने पहले से कर दिया.
ओके मैम, थैंक यू. मैम कैन वी लीव?
यस,
थैंक यू मैम.